Hi everyone, this is the third section of Chapter 4, Congruent Triangles. We're going to be talking in this section about how to identify corresponding parts, that is, parts of two different congruent triangles that correspond to each other, such as segments or angles, and we're going to prove triangles congruent using congruence of those corresponding parts. Okay, so let's get started. Congruent. We've talked about that all year. Congruent directly translates to equal measure. And we can have congruent segments, as we've been working with all along, congruent angles. This time we're going to be focused on congruent polygons, more specifically triangles. Okay, so congruent polygons, all corresponding angles and sides are congruent. I'm going to abbreviate. So, statement of congruency. Well, let's take a look at how what I mean by corresponding. So, we've got two triangles here. We have PRQ and we have KLJ, and we've got angles and segments that are being marked congruent. So we use often the angles to kind of get our bearings. That my dog is barking a lot here, sorry about that. Let's look at this single slash here. So PR is marked as congruent to KL, and we can sort of see that it's situated in between the double arc and the triple arc. So they are corresponding. Likewise, we've got the double slash, which is PQ, and that is corresponding to JL, which is also a double slash, and that's nestled in between a single arc and a triple arc in both cases. And then finally we have QR, which is the triple slash, and that's a side that's included between a single arc and a double arc. So if we were to write a congruency, we could see that all of these angle pairs are congruent and all 6 of the segment sides are congruent. So if we were to write a statement of congruency, then we would say triangle, the symbol triangle, and I'm going to start out with Q, R, P, and I didn't have to start out that way, but I can actually write these in any order that I want, but I just went from the single arc to the double to the triple, and I'm going to use my congruency symbol here. And now the order is important. I have to put the next triangle vertices in a certain order, and it has to match this order here. So Q is the single arc, so J has to be in the first position. R is the double arc here on the angle, so I have to put K in the corresponding position. And finally, P is the triple arc, so I'm going to have to put L in that position. And you can see each pair is in corresponding order. Okay, every pair tells you a lot about these two polygons. If I didn't even have a diagram, I would be able to just look at this here and be able to write 6 pieces of information. I can see just by the order here that angle Q is congruent to angle J, angle R is congruent to angle K, angle P is congruent to angle L. I don't even need a diagram. And then just by the order here of the vertices, I can tell 3 different pairs of information on segments. QR is congruent to JK. QR is the first and second position, and JK is the first and second position. Likewise, RP is congruent to KL. That's in the second and third position, and then I can look at the first and the third and see that QP is congruent to JL just from looking at that statement of congruency. All right, properties of congruent triangles. We are going to use the same properties we've used first with algebra, then we used with segments, then angles. We're going to use all the same properties with our triangles. So reflexive property of triangle congruence. Well, when we were looking at numbers, we could say 5 equals 5. 5 equals itself. Looking at variables, x equals x. Looking at segments, we could say AB is congruent to AB. Well, in this case, reflexive property says that a triangle is congruent to itself. For example, I could look over here in my triangles and I could say triangle ABC is congruent to itself. Likewise, symmetric property of triangle congruence. When we looked at, for example, segments, I could say AB is congruent to CD, and then I could spin those around and say, well then, CD is congruent to AB. So we can also apply the same symmetric property with triangles. So I could say if, triangle ABC is congruent to triangle, let's say, EFG, then I can spin that around and say, well, triangle EFG is congruent to triangle ABC. And finally, the transitive property of triangle congruence. Remember, this is a subset or a special case of substitution. We've been using this quite a bit algebraically as well as with segments and angles. So for example, I could say if triangle ABC is congruent to triangle EFG and triangle EFG is congruent to a third triangle, such as JKL, I'll say, JKL, then that first triangle, ABC, must be congruent to the third, if they're all congruent to each other. Okay, great. We are going to be using a theorem called the third angles theorem quite a bit here going forward in some of our proofs. So let's take a look what it's all about. Basically, in words, it says if two angles of one triangle are congruent to two angles of another triangle, then the third angle pair must also be congruent. And if we just looked at that from a number sense, I think it's pretty obvious. So I'm just going to make up some numbers here. If angle C were 50 and angle B, for instance, were 60, and K is congruent to C, so that's 50, and J here is congruent to B, so that's 60. 50 plus 60 is 110 degrees. We need 70 more. There's 70 left for the third angle. So I think it's easy to see that that third angle pair must be congruent. It's the only thing that works arithmetically. Okay, so let's prove that though. We've got angle C is congruent to angle K, and angle B is congruent to angle J. I'm going to try to prove my conclusion here that A is congruent to L. Okay, so both of those were given. Okay, so let's see how we might want to prove that A is congruent to L. Let's say that angle, we know what they all sum to, so let's say angle A plus angle B plus angle C is going to sum to 180. And we could say the same thing for the other triangle, angle L plus angle K plus angle J is going to sum to 180. This is called the triangle angle sum theorem, which we've been using for a while now. Now, if this equals 180 and this equals 180, they equal each other. So we have angle A plus angle B plus angle C equals angle L plus angle K plus angle J. And now I'm told that some of them are congruent. So A, B, and C, I know that C is congruent to K up here. So if you look in our given, C we were told is congruent to K. So I'm going to go ahead and replace that. And B is congruent to J, so I'm going to replace that. I'm just going to circle B and C here so you know what's being swapped out. Okay, so angle A plus, I'm going to put in for angle B, angle J, and for angle C, I'm going to put in angle K, equals angle L plus angle K plus angle J. And the only thing we did there, oh, by the way, I never gave a reason up here. This is transitive or substitution. And next, we just purely substituted equal values. Okay, substitution. Sorry about my mess. All right, now we can finally conclude that angle A must equal angle L. And why is that? Because we subtracted. We used our subtraction property of equality. And the way we did that is we subtracted J from both sides, and we subtracted K from both sides. Therefore, A must be equal to L. Great. All right, in the diagram, we are told that triangle ITP is congruent to NGO. Now, before you do anything, I want you to just don't even look at the diagram, if you will. Just trust the statement of congruency. We know that angle I is congruent to angle N. We know angle T is congruent to angle G. Angle P is congruent to angle O. And we know that just from that statement of congruency. So if I look over here, I see that angle T is 75. Well, that's congruent to angle G, so I can go ahead and put 75 in here for angle G. And also, I could see that angle I here is congruent to N, and that's a 65, so I'm going to go ahead and put that in for N. And finally over here I've got three angles. One of them is an algebraic expression, so I can write an equation here using the triangle angle sum. I can say 6y minus 14. Hopefully you see that this little arrow is showing you that that goes in there for the angle. 6y minus 14 plus 65 plus 75 equals 180. And I've got 6y. And if I combine my constants here, I will get 126, I think, equals 180. If I subtract 126 from both sides, I get 54. Whoops, I don't want 5y, I want 54. And if I divide both sides by 6, I get y equals 9. And you should go ahead and substitute that back in and make sure that all the angles make sense. Now let's take a look at the segments. So over here we see NG is an algebraic expression. So what can we do with that? Well, just looking, not even looking at the diagram, just looking here at the statement of congruency, I know that IT is congruent to NG. I know that TP is congruent to GO, and I know that IP is congruent to NO. So let's take a look at where our algebraic expression is. It's in here for NG. So NG is in this statement here. NG is congruent to IT. So let's go ahead and write that. We've got NG is congruent to IT, and that is 7 5/10. We've got x minus 2y equals 7 5/10. I'm trying to solve for x, so I'm going to still have my x, but I'm going to subtract here 2 times y, which is 18, and that's 7 5/10. I'm going to add 18 to both sides, and I think I get 25 5/10 for x. All right, let's keep moving. All right, here in the diagram we have a statement of congruency. Triangle FHJ is congruent to HFG. Now let's take a close look at these vertices in their order. So FHJ is this triangle on the left, and we see that this little angle in there is going to be congruent over here to the H. So go ahead and mark that. They are congruent. Next, we've got H in the left triangle is congruent to F in the right triangle. So let's mark that. we've got H over here in the left is congruent to F in the right. And finally, J and G. So our third angle here and G. So all of those angles are congruent. Now let's take a look at the segments. We've got FH in the left is congruent to HF in the right. I'm going to use blue here. So FH in the left is congruent to HF in the right. And that would be a reflexive property. As you can see, FH is congruent to itself, so I'm just going to mark that. We also have HJ in the left is congruent to FG in the right. And finally, FJ is congruent to FG in the right. Okay, so we have all our congruencies. Now let's find values of x and y. So we've got an angle here, 6x plus 8 is going to equal 35 degrees. So that gives you a nice equation to solve for x. And we also have two segments. 2y minus 3 is going to equal 2 5/10. So pretty simple algebraic equations. I'm going to subtract 8 from both sides, and I get 27. And I'm going to divide both sides by 6. And I know that 6 goes into 24 4 times. And I have 6 as a remainder. So this is going to equal, well, if you like decimals, you could put 4 5/10. And over here, I'm going to add 3 to both sides. And I get 5 5/10. And I'm going to divide both sides by 2. And I get 2 and 3, well, 7/500 if we stay in the decimal. Okay, great. Example 3. Write a 2-column proof. So we have a bunch of given information here. Angle L is congruent to angle P. Now, if they weren't marked over here, we would mark the diagram. In fact, it's a must-do to mark the diagram. Segment LM is congruent to PO. LM here is congruent to PO. It was marked for us. LN is congruent to PN here. And MN is congruent to NO. Oh, actually, that is a typo. So here, hopefully you can see that that is not correct. This should say NO or ON. Okay, great. Prove that the two triangles are congruent. So let's take a look at this. And by the way, I think the typo is carried on down here as well. This came straight from the textbook as well. So sometimes books have a problem. Okay, so all of this information we would restate, and it's the given. Next, angle LNM. LNM is congruent to angle PNO. PNO. So they're saying these two angles are congruent. Of course, we know that they are congruent because they are vertical angles. And all vertical angles are congruent. I'm going to abbreviate here. Angle M is congruent to angle O. Angle M is congruent to angle O. Well, why would that be? I'm going to go ahead and mark it first. Well, we just talked about that in these notes. If we have one triangle with two triangles with two pairs of congruent angles, that third angle must be congruent. So we're going to call that the third angles theorem. They must be congruent. And finally, why are the two triangles congruent? Well, all of the corresponding angle pairs are congruent and all the corresponding sides are congruent. So we're just going to say all corresponding parts are congruent. So they must be congruent. All right, very good. And I think that does it. Hope this helps. Please subscribe.